In section 3.2, we're going to focus our discussion of polynomial functions onto a specific type, and that is the quadratic functions. A quadratic function is a polynomial that has a degree of 2. So in other words, its highest power will be a 2, and it can be written in the form f of x equals a number, times x squared, plus b, a number, times x, plus c, another number, where the a value cannot be a 0. Because if the a value is a 0, that first term disappears, and it's no longer a quadratic function. So quadratic functions are all transformations of our toolkit function, f of x equals x squared. So let's do an example. It says a backyard farmer wants to enclose a rectangular space for a new garden. She has purchased 80 feet of wire fencing to enclose the 3 sides, and will put the 4th side against the backyard fence. Find a formula for the area of the area enclosed by the fence if the sides of the fencing perpendicular to the existing fence have a length of L. So let's see if we can take this apart and get a picture going and figure out what's going on here. So this lady has purchased 80 feet of fencing. She's going to enclose 3 sides of the garden. The 4th side is going to be a fence that's already there. Find a formula for the area enclosed by the fence. So a couple things we want to remember. This is going to be a rectangle. So the area of a rectangle is area equals, and there are different ways to say this, but I'm just going to say length times width. Sometimes it's base times height. I'm just going to go length times width. Okay. So they also said, and I forgot to read this part, if the sides of the fencing perpendicular to the existing fence have a length of L. So let's go ahead and draw a picture. So let's say that that's our fence. They're telling us that it's a rectangle and our fencing comes out, and these both have a length of L. So what we don't know then is the length of that 3rd side. Let's, so for our formula, I guess if we think about that, if we call that length the capital L, we know that part. But the question is, we have to figure out what is this 3rd side. Now that's where that 80 feet of fencing comes in. She has 80 feet of fencing. So let's just do a picture here, a separate picture. I'll erase it in a second. But if I told you that she used 10 feet of fencing here and 10 feet of fencing here, and she had 80 feet, how could we figure out that 3rd side? Well, we would take 80 feet minus the 20 that we've already used, and we would know that this side would be 60. So we're going to use that thinking, even though we don't know what actual number it is, we're going to do the same thing. We're going to take 80 minus the 2 L's that we have, so minus 2L, and that is going to be our length of the 3rd side. So that's going to be the width, and in our example here, or our equation I should say, we're going to put in for the width 80 minus 2L. Now if we wanted to, we could distribute. Area equals 80L minus, and that's distributing the L, and then we would distribute the L over here, minus 2L squared. And finally, if we wanted to put it in standard form, we would put the minus 2L squared first and the 80L after that. So really, any of these 3 answers I would be okay with. Later on, we are going to use one of them to help us out. But that's how we would find a formula for the area enclosed by the fencing. And that way, depending on what the L value is, that will change the 3rd side, which will also change the area. But that's how we do that, but don't be afraid to draw a picture in a case like that, because there's a lot of words there. The vertex of a quadratic function, or of a parabola, that's the shape that we're making, is the point where the function changes direction. In other words, it changes from increasing to decreasing. So our vertex is going to be, in this case, in our parent function, right down here at the point 0, 0. And we can see on the left-hand side, this function is decreasing, and on the right-hand side, it is increasing. So again, decreasing means it's going down from left to right, increasing means it's going up from left to right. And every parabola will have a vertex like that, whether it opens down or up, or it's been moved around. It doesn't matter. It will always have a vertex. And there it is. So example 2, write an equation for the quadratic graph below as a transformation of the parent function, or the toolkit function, f of x equals x squared. Then expand the formula and simplify the terms to write the equation in standard form. So 2 parts to this question. First, we want to find the equation as a transformation. So let's start out by identifying our vertex. Notice that our vertex is right over here at -2, -3. Since the vertex is normally at 0, 0, this thing is moved over 2 and down 3. So we want to figure out how do we move a function, and let me write our parent function here. So our parent function is y equals x squared. If we're going to do a transformation, we're going to have y equals, and then our x is in parentheses, squared. And how do we make it move to the left 2 spaces? Well, if you remember, to move it to the left 2 spaces, we're going to add 2. It's in with the x, and it always works backwards of what we'd expect. Then if we want to move it down 3 spaces, we're going to subtract 3. Okay. Then, and here's the part that tends to be a little bit tricky for people. Remember, we can have stretches and shrinks and things, and those numbers always go into the front. So that's where we have to do a little bit of math here. So here's what we do. I'm going to erase my vertex here. I can't use that point again because I've already used it. But I want to find one other exact point other than the vertex. So we have to be really careful on these graphs, and you might want to zoom in when you're doing your homework. But notice we have an exact point there. It looks like we have an exact point up there, and over here. So I think we have 4 other exact points to choose from. I am just going to use the y-intercept as long as I've got it, because that way one of my numbers that I'm going to plug in is going to be a 0. So here's what we do. We're going to, and I'm going to do this in orange just so we can keep track of what we're doing here. So the y value in this case is -1 equals, and what happens is we have to figure out some number that goes in front of this parentheses. So everything else, whoops, I just did that wrong. Everything else gets copied down, I was going to say, except for the x, which we're replacing the x with, since that ordered pair is 0, -1, we're replacing the x with a 0. And then we just have to do the math here. We're going to add 3 to both sides so that we can figure out what a is. And that's going to give us 2 equals a. And then obviously 0 plus 2 is 2. And that's being squared, so that's going to give us 2 equals, 2 times 2 is 4. And when we divide, we find out a equals 1/2. So we can take that, and we take it, and we put it right back up here, and now we know what goes into that gap is a 1/2. So this is our answer for writing this equation as a transformation of our parent function. Now, the other thing that they told us to do in this question was then expand it and write it in standard form. So what we have to do then is take that thing and multiply it out. Now, I obviously don't have enough space here, so I'm going to have to erase. So hopefully you've got all this written down. If not, you can go back and rewatch it. But we're going to take that equation that we have here and multiply it out and put it in standard form. So what that means is we're just going to leave the y, and we're going to leave the 1/2 for now, because the first thing we have to do is that exponent. So I'm actually going to come over here and do that work over here. X plus 2 squared means x plus 2 times x plus 2. And we distribute. So x times x is x squared. X times 2 is 2x. Then 2 times x is 2x again. And 2 times 2 is 4. So if we put that all together, we have x squared plus 4x plus 4. So that is the stuff that's in the parentheses here. X squared plus 4x plus 4. And then we're just going to copy down the minus 3 at the end. So then we need to distribute. So the 1/2 distributes. Y equals 1/2 x squared. 1/2 times 4 will be 2x. 1/2 times 4 again will just be a 2. And then we have the minus 3 at the end. And then finally we can combine our like terms at the end. So our answer in standard form would be 1/2 x squared plus 2x minus 1. So that is the standard form. And then you can see above you've got the transformation form. So two different equations actually describing that same curve. We already used this in our previous example, but standard form is the one that we learned right at the beginning, the ax squared plus bx plus c. That's kind of a standard form, just like slope-intercept form is for lines. But the transformation form is going to look like this. Notice that's the same in both versions. A, and then parentheses, x minus h squared plus k. So that's our transformation form because you can see how far it's moved left and right, and you can see how far it's moved up and down from the h and the k. So the vertex of our quadratic function is located at that point, hk, because that gives us the left and right shift and the up and down shift, where h and k are the numbers in the transformation form of the function. Because the vertex appears in the transformation form, it is often called the vertex form. And usually when I talk about it, I will say vertex form because in pretty much all the other books that I have used in the past, they always called it vertex form. So here's how we find the vertex of a quadratic if we are given standard form. So if you're given standard form, remember the first number is the a, the number in front of the x is the b, and the number that's by itself, the constant, is the c. And based on that, we are able to use this little formula to help us find the x-coordinate of our vertex. Okay, the opposite of b over 2a. Once we know that, and this part, I don't really like this. This is all a bunch of complicated stuff. At least it looks complicated. But all this means is, like you would make a t-chart, you plug the h value into the function. Which means this, right? To find the k value, you just plug 8, you make h your input. So that's really all that's saying. And then it's saying, well, we know that h is the opposite of b over 2a, so they're simplifying that way. There's really no reason to do that. Just figure out the number and then plug the number in. And that will give you the k value here once you do that. So that'll be the y-coordinate of your vertex. So example 3, find the vertex of the quadratic and rewrite the quadratic into transformation form or vertex form. So we're going to start out with h equals, and our formula said the opposite of b over 2a. Now I always like to identify this because sometimes this messes people up. The a value here is 2. The b value is -6. And I think I ran out of space. The c value is 7. So now we know what letters we should be plugging in. In our case, it's going to be a negative and then -6 for the b. And on the bottom, 2 times a, and a is 2. So the opposite of negative 6 is positive 6, and on the bottom we have 2 times 2 is 4. So that gives us 3 halves. So that means in our vertex, the x-coordinate of the vertex, the h value, is 3 halves. Once we know that, if we want to find the y value, we're just going to plug the 3 halves in. So we're going to do f of 3 halves, which means it's going to be 2 times the input squared minus 6 times the input plus 7. And as we just determined, our input here is 3 halves. So we're going to put that in for both of those. Now we'll just evaluate. We have a 2. 3 halves times 3 halves, 9/4. Minus, and then 6 times 3 halves is going to be a 9, and then a 7, plus 7 at the end. So 2 times 9/4 is 9 halves. This ends up being minus 9 and plus 2, or plus 7. And then when we do this, we end up getting negative 9 halves, and then plus 7, which makes it, what is that, 2.5? Yeah, it'd be 5 halves. I guess I'll just leave it as improper fraction since that's what I've got. So 5 halves. So that's the vertex. Now we're not done because the whole question was to put it in vertex form. So here's how we do it. Remember, vertex form looks like this. F of x equals a times x minus h squared plus k. So in our case, that's going to be f of x equals, now the a value, remember, from the very beginning doesn't change, so that's 2. Then x minus the h value, and the h value is 3 halves. Come on, there you go. And then plus the k value at the end, which was 5 halves. So there is our equation. Notice that is the exact same equation as this one, but the one on the top is written in standard form. The one on the bottom is written in vertex form. And the vertex form, the benefit there is you can tell exactly what's happened. This thing has moved to the right 3 spaces. It's moved up 5, or not 3 spaces, to the right 3 halves of a space, 1.5 spaces. It's moved up 5 halves, or 2.5 spaces, and then it's been stretched vertically by a factor of 2. So that's why it's called transformation form, is because you can see the transformations. It's also called vertex form because you can see the vertex really quickly when it's in that form. But those two equations are describing the exact same parabola. Okay, going back to our farmer who was building their garden in the backyard against the fence. What dimensions should she make her garden to maximize the enclosed area? Now here's where we want to go back and we want to kind of think about what's going on. Parabolas have 2 basic shapes. They either open up or they open down. And remember, the leading coefficient determines which one is which. So since this leading coefficient, even though it's not in the right order, is right there, we know this parabola opens down, and so therefore, this is the area function. Therefore, if we want to find the maximum, we're going to look for the vertex, and we're going to find the vertex. The same thing would happen if it opens up and you wanted to find a minimum, you would look for the vertex. So for parabolas, if you want to find a maximum or a minimum, you're always going to look for the vertex. So let me get rid of my stuff here and let's do the work. So knowing that we're looking for the vertex, we're going to use our little formula. It's not x in this case, it's L. So L equals the opposite of B over 2A. That's not a minus sign, it's supposed to be equals. Okay, now be careful here. Let's put it in standard form. This would be negative 2L squared plus 80L. That means A is negative 2, B is 80, and C is 0 in this case because there is no constant term. So plugging these in, we have negative, and then the B value is 80 over 2 times a, which was negative 2. So that's negative 80 divided by negative 4, and that gives us 20. Now, really, that's as far as we have to go, because what does this say? L equals 20. If you remember our picture, this was our picture. And this was 80 minus 2L. So if we know now that this is 20 and this is 20, we can just subtract to figure out the third side. And the third side is going to be 80 minus 2 times 20. So that's 80 minus 40. And the third side is going to be 40. So when they ask for what are the dimensions that will give her the maximum area, our dimensions are going to be where the length is 20 feet, and then I guess the width, we're calling it, would be 40 feet. And those are the dimensions that will give her the most area in her garden to plant amazingly wonderful vegetables and fruits. When we are looking at these, and we've already mentioned a couple of these, but when we're looking at parabolas, there's always going to be one of 3 options for how many horizontal intercepts they have. So the first option that we're going to consider is that the entire parabola is completely above the x-axis. And in that case, notice since it never crosses the x-axis right here, since it never crosses this line, there are 0 horizontal intercepts. Now I will say another option is it could be that the parabola opens down and is completely below the x-axis. Either way, that's an option, that there might be no horizontal intercepts. The second option is if it has 1 horizontal intercept. So in other words, it's coming and just touching the x-axis at that one point, and then it has 1 horizontal intercept. And again, you always have the option of, well, maybe it's coming up and touching from the bottom and going back down. Okay? And then the third one, and this is probably the most common one that we see, but is where it intersects in 2 different spots on the horizontal axis or the x-axis. So that gives us 2 horizontal intercepts. And again, I will mention that just like the other 2, it is possible that a graph could come up from the bottom and intersect at 2 different points. So you always have those reflections, but they're just drawing examples. But the examples, sometimes people forget that those parabolas can be reflected, and they might look like this where they're opening down on these problems. Example 7 says find the vertical and horizontal intercepts. And if you remember, we did this in the last section. Last time it was already factored for us, so this time it's not. But we're going to start out, let's go ahead and start out with the horizontal intercepts. To find the horizontal intercepts, remember we take the f of x and replace it with a 0. So that's going to say 0 equals 3x squared plus 5x minus 2. And at this point, the only method we have of solving those is factoring. So let's go ahead and do our factoring. We take the 3 times the negative 2, and that gives us negative 6. And then we want to examine our signs. So we look at this sign, since it's a negative, if you remember from our review, that means the signs are different. One is positive and one is negative. After we know that, we go over here and we look at this. Since they add up to be a positive, that means the bigger one has to be positive. So if we're listing our numbers, bigger one's positive, negative 1 and 6 is our first option, and actually we can stop there because that works. So let's write this down. 0 equals 3x squared. Remember, we're replacing the 5x with a minus 1x and a plus 6x. And then minus 2. And then, if you recall, we factor by grouping. So we group them together. In the first group, we can factor out an x, and we have 3x minus 1 left over. We have to factor out the plus sign, and in the second group, we can factor out a 2, and we have a 3x minus 1 left over again. Then, now that we've done that, we're going to be able to factor out the 3x minus 1. And what we have left is the x plus 2. And then we take those values and we set them equal to 0. So each factor, 3x minus 1 equals 0, and x plus 2 equals 0. Once we've done that, we're going to solve. So add 1, and that will give us 3x equals 1. And then divide by 3. So we get x equals, whoops, I went off the bottom of the screen. X equals 1/3. Now remember, they asked for the intercepts, so that one is going to be 1/3, comma 0. The next one is much quicker. We just subtract 2, and we're going to get x equals 2, or sorry, x equals negative 2, and then that one will be negative 2, comma 0. So these are the two horizontal or x-intercepts. Then we can go over here and we can find the y-intercepts. I'll switch colors here. I guess I'll use purple. So for the y-intercepts, remember, we just replace the x with a 0. That makes this much easier. So it's going to be f of 0, and that is 3 times 0 squared, plus 5 times 0, minus 2. And so when it's in standard form like this is really easy because this cancels to be 0 and this cancels to be 0, and all we have left is negative 2. So f of 0 equals negative 2, and that means our intercept is 0, comma negative 2. So that is the vertical intercept. And remember, like I said last time, that's always how you find horizontal intercepts. Replace the f of x or whatever the function is with a 0. And to find the g of x, or sorry, not the g of x, but to find the vertical intercept, you're always going to replace the x with a 0 or whatever variable you happen to be using. Now, one of the key things that we need to understand when we're dealing with quadratics is what we call the quadratic formula. The quadratic formula gives us the ability to solve any quadratic function, or I should say quadratic equation, even if we can't factor it, because not all quadratic functions can be factored. And I think I mentioned that in our factoring review. Sometimes you just can't do it. And if we run into an equation that we can't factor, then this is our other option. And this will work every time, but the quadratic function, again, you're writing things in standard form, or the function is given in standard form, ax squared plus bx plus c. The way we do this is you get this formula, x equals, and then we have this big fraction. And the top of the fraction says the opposite of b plus or minus the square root of b squared minus 4ac. And then the denominator of our fraction is 2a. So it is one big fraction, but notice you don't actually have to solve for x because the x is already by itself. What you're going to do is plug in the numbers, the a, b, and c values, plug in the numbers, and then just simplify as far as you can with that big fraction. So that's what we're going to be working on as we deal with this one. So example 8, find the horizontal intercepts of the quadratic function given here. The first thing we're going to do is rewrite it, because when we find intercepts, we put in a 0 here. The other thing I would look at, I'd look at possibly trying to factor it. And in equations, in fact, remember we looked for a greatest common factor, and in this case they all have a 2 in them. Well, since this is an equation and it's equal to 0, we can actually just divide everything by a 2, because we're not really, our goal is not to factor this, our goal is to solve the equation, and so that just makes all the numbers smaller and easier to work with. So that would be x squared plus 2x minus 2. Now, if we try to factor this, we would take 1 times negative 2, which is negative 2, and we would find the factors of -2, or sorry, first we would say, okay, the signs have to be different, one positive, one negative, because that multiplies to be a negative. And then we would look here and we'd say the bigger one has to be positive, and we'd start writing down our numbers, and we would have a -1 and a +2, and that's the only option. And the problem is that does not equal 2, that equals 1. So this is a case where this cannot be factored. So I'm just going to go back, and we may have guessed that since it's right after we talked about the quadratic formula. But what I'm going to do is I'm going to identify A, which is 1, B is 2, and C is -2. Then we're going to see if we can use the quadratic formula to help us solve this. So just as a reminder, and I know it's on your notes there, but I'm going to write it here, x equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. And all we're going to do is plug in the numbers. So x equals the opposite of b, so that's the opposite of 2, and I always like to put parentheses around my input values. And then we're going to have 2 squared minus 4 times a, which is 1, times c, which is -2, over 2 times a, which is 1. Now I will mention at this point, if you didn't divide out that 2, that's fine. You'll still get the right answer. You're just going to have some reducing at the end that you'll have to do that I won't have to do doing it when I do it this way. So here's, when we simplify this, here's the process we go through. I always take care of that outside part, -2. And then I start simplifying the inside. We know that 2 squared is 4. And again, very important to put parentheses around that, because if you don't put parentheses around the b, and the b value happens to be negative, your calculator will lie to you, and it'll tell you that whatever that number is, it's a negative. So you want to make sure you put parentheses around that, because when we square that number, it's always going to end up being positive. So in this case, 2 squared is 4. And then notice we've got a -4 times a +1 times a -2. That's going to end up being +8. So I guess I don't need this much of a line here. And on the bottom, 2 times 1 is 2. So that gives us -2 plus or minus, and then we can go ahead and simplify the inside of the radical, because that's just 12. Okay, now at this point, it looks like we're going to be able to do some reducing or simplifying. So what I do here is I'm going to split this up into 2 separate fractions. Because a lot of times people get mixed up and they'll try and simplify, but they'll only put the 2 with one of the fractions. So we need to break up that 12 inside the radical. So remember, we can break that up into parts. Let's say 3 and 4. And then 4 breaks up into 2 and 2. And remember, we're looking for pairs. So this is going to be written as -2 over 2 plus or minus. The 2 gets to come out on the outside, and the 3 has to stay stuck in the inside of the radical. And then we can reduce. So hopefully we're confident that -2 divided by 2 is -1. And then notice, so yeah, let me switch colors. So that will cancel to be a 1, and those will cancel out to be 1s. We don't have to write the 1 in front of that radical. If you want to, you can, but remember that it's understood to be there. And we get our answer. Now remember, that is actually 2 answers. And let's see, they asked for the intercepts. So I'm going to undo my box there. Because if I'm trying to find the intercepts, here are the intercepts. -1 plus the square root of 3, comma 0. And -1 minus the square root of 3, comma 0. That's what that plus or minus does. It actually gives us 2 separate answers. And since we're going to write them as intercepts, we want them written as ordered pairs. So all of our x-intercepts, or our horizontal intercepts, will have a second value of 0. So that's the quadratic formula. That's how that process works. And the interesting thing is, sometimes the answer comes out nice, sometimes it comes out messy, but you do the same steps every time. And that makes it kind of nice. If you like steps and you just like doing the same thing every time, quadratic formula is, excuse me, an option that works pretty well for that. Example 9. A ball is thrown upwards from the top of a 40-foot tall building at a speed of 80 feet per second. The ball's height above the ground can be modeled by the equation given here. What is the maximum height of the ball? Now, one thing we need to understand is all this information at the beginning, while it's interesting, it's unnecessary because they gave us the function that we're going to use. So once again, looking at this and using a little bit of critical thinking here, it's a negative leading coefficient, it's a parabola, we know it's been reflected, and so it should make sense to us that it will have a maximum up here at the vertex. That's always where we look for maximums or minimums. So let's go ahead and do this one. Let's identify, in this case we're using t's. Whoops, let me switch colors back to white. So t, instead of x equals the opposite of b over 2a, it's going to be t equals the opposite of b over 2a. And in this case, let me just use colors, I guess. So I'm going to say my a is the negative 16. My b is the 80. And I'm not going to need it, but just so we practice identifying, the c is a 40. So the opposite of b, opposite of 80 over 2 times a, and we know that a is negative 16. And that will be negative 80 over negative 32. And if we reduce that, it's going to be 5/2. Now in this case, I'm going to go ahead and change that to 2.5 because this is probably 2.5 seconds, and very seldom would we say, oh, it's been flying for 5/2 of a second. I mean, maybe, but... Now, in this case, notice they're actually looking for the maximum height. So we actually have to plug this one back in to find the maximum height. So we're going to do h of 2.5, and that equals negative 16 times the input value squared plus 80 times the input value, and then plus 40. And of course, I don't have my calculator here, so we're going to see how good my mental math is today. Actually, let's see. So we're going to put in the 2.5 here and here. So let's see. 2.5 squared is, I think it's 6.25. And we're going to multiply by that a negative 16. Okay, let me do the second one first. I think there's a pattern here, so I think this is, now it's all going away. I think that's 200. I think this is 100. Let me double check. 6.25. 96. Yep, okay, so minus 100 plus 200 plus 40. We add those together, and again, you should do this on a calculator. I would if I had one sitting here, but I don't. So 140 feet is going to be our maximum height. That's the height, come on, after 2.5 seconds. So this is our maximum height. The second part of the question says, when does the ball hit the ground? So again, we've got the same situation. When does the ball hit the ground? Well, here's again, you want to think about this. If the ball hits the ground, that means the height is now 0. So does it make sense if we're thinking about a graph, we're looking for the x-intercept, or the t-intercept in this case? So again, the first thing I'm going to do, if I can, and in this case I can, is divide everything by a 4, because 4 goes into, actually an 8, because 8 goes into each of these. And also, I want this first term to be positive, because it's just nicer to work with, so I'm going to divide everything by a negative 8 instead of a positive 8. And so that's going to give us positive 2t squared minus 10t and minus 5. Now, we could go through the process of trying to factor that, and I'm gonna go ahead and do that just to show you again that you could try it. But I will tell you that in general, if there's a number in front of the t squared, I usually go straight to the quadratic formula. But just so that you see it, I'm going to show you. So 2 times negative 5 is negative 10. We know the signs are different. And the bigger one is negative. So factors of negative 10, where the bigger one's negative, 1 and negative 10 doesn't add up to negative 10, and 2 and negative 5 won't, and those are the only options. So this cannot be factored, and that's what I was showing you, but like I said, usually if there's a number in front of the x squared or the t squared, what I do is I just go ahead and go straight to the quadratic formula. So let's identify a is 2, b is negative 10, c is negative 5. All right, and let's go over here and we'll plug these into our quadratic formula. So in this case, it's not x, it's t. So I'll be correct. T equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. So plugging in our values, that's going to be t equals the opposite of b. That means the opposite of negative 10 plus or minus the square root of negative 10 squared minus 4 times 2 times negative 5 over 2 times 2. So we do our first step of simplifying, and we're going to get 10 plus or minus, and this is again where it's important to use those parentheses so the calculator doesn't lie to you, 100, negative 10 squared is 100, and this is going to end up being plus 40. Over 4. Okay, and then as we look at continuing to simplify, 10 plus or minus, this would be 140 over 4. And in this case, I'll just tell you, normally in math we look for the exact answers, but when they say, when does the ball hit the ground, you are never going to tell somebody when the ball hits the ground by saying, oh, it's the square root of 17 or whatever. You would round this off. So this is a problem where you would stick this into your calculator and figure out the answer. So I don't have my calculator here, but what we would do is our two options are this. Remember, we're going to have 10 plus the square root of 140. Oh, I'm off the screen. Okay, hang on. Okay, let's move over here. Hopefully I'll have space. So we would have 10 plus the square root of 140 over 4, or 10 minus the square root of 140 over 4. And this second one, I'll just tell you, when you start doing this, a couple things. You will need to put parentheses around your numerator when you type it in. And the second one, as I was mentioning, when you do 10 minus the square root of 140, you're going to get a negative answer. So when you divide it by 4, it's going to be a negative answer. And in the context of this problem, does it make sense that the ball hits the ground a negative time after it was thrown? And the answer is no. You're not going to get a negative answer for time, so that one goes away. Let's see if I can estimate this. 140 is about, square root of 140 is going to be about 12, so 10 plus 12 would be 22-ish. Divided by 4, it's going to be about 5.5. So around, I'm going to guess I don't know. I'm going to guess 5.4. But we're going to see the answer, I think, in just a second here. So you type that into your calculator, and you're going to get your answer, and I'm thinking it's going to be close to 5.4 seconds. You want to make sure you label it, seconds. So we'll see how close I was with my guess since I don't have my calculator here. Oh, 5.458. Okay, so I was pretty close. But again, you can type that into your calculator, and a lot of times the computer program wants 3 decimal places, so if it tells you to round somewhere else, just go ahead and round to whatever it says. But that's the process that you go through. And again, that's another example of using the quadratic formula. That's the end of section 3.2, and you can go ahead and work on those. Again, please don't be afraid to ask for help if you get stuck on something, and I will see you later.